Now, to illustrate the solution for the problem, I've got the whole solution shown here, but what I want to do is to give a bit more of explanation about how we go about approaching the row reduction. Now, where we start initially is always in the first column with the first element right there. Now that, because we know we're going to try to get that matrix there looking like the identity matrix, that number there has to be 1. Now it's already 1, so we can just accept that. But if it wasn't 1, we'd have to get it to 1. So if that number there was 5, what I would do is divide that top row by 5 to reduce everything down as required. If one of the other rows had a 1 in the first column, I would simply swap the rows to put that at the top. Now, in this particular case, we notice that that number there is already 0, so we don't have to worry about that. So what we need to do is to convert the -3 back to a 0. So the way we do that is if I take the 1 there in the top column, top of the column, multiply it by 3, that makes it 3, and then I add it to that, that will then eliminate the -3. So what I need to do then is I take that whole first row there, multiply every element by the 3, and then add it to that row there. So what we end up with is 3 ones are 3, add it to that, you get 0. 3 ones are 3, add it to that, 3. 3 ones are 3 plus 1 is 4. 3 26s, add it to -1 is 77. 3 26s are 78. Now that we're at this stage, we've now noticed that that first column right there is all in the right form. It's 1 0 0, so that's fine, so we can ignore that now. And what we do now is we go to the next column, the second one. Once again, you work from the identity matrix positions down the diagonal. So the next thing we have to do is to convert that to a 1. So to get there, we can just divide the whole row by -2. So, if we do that, no, because that's 0, that doesn't do anything. It doesn't change. -2 divided by 2, -2 is 1. 1 divided by -2 is -0.5. 0 divided by -2 is still 0. So we now have the 1 in the diagonal position for the second row. Now what we need to do is to convert that 1 there and that 3 there back to 0. So to convert the 1 back, I would subtract the second row from the first row. Notice when I do actions like this, if we go into this first column, anything I do with those two zeros essentially won't change anything. I can multiply it by a number, I can subtract or add it a number, divide, doesn't matter, because they're zeros, they don't influence anything on that first row, so that 1 will remain the same. Now, so to get rid of the 1 there, I will subtract that. So 1 from 1, 1 minus 1 is 0. That minus 0.5 is 1 plus 0.5, which is 1.5. 26, that's 0. Subtract 0, doesn't do anything. Now for the bottom row down here, what we need to do is to change the 3 there to a 0. So I have to multiply 1 by 3 and then subtract. Multiply that by 3, then subtract to the 4. So multiplying that by 3 is -1.5. Then I'm subtracting it, so it becomes positive, so it's 4 plus 1.5, which is positive 5.5. Once again, multiplying that by 3 and subtracting it from 77 doesn't do anything because it's 0. So we've now gotten this far. We have the first two columns correct, and then what we do is we go into the diagonal position again and we convert it first. Now notice at the moment it's 5.5, so if I divide it by 5.5, it'll convert back to 1. So I have to divide 77 by 5.5, obviously on my trusty calculator. That reduces it to 14. Now I have all of my diagonals, my diagonal values at 1 as I require them. All I need to do now is to convert these two values here back to 0, and I'll be done. So to convert the 1.5, what I'll do is I multiply 1 by -1.5 and then add it. So take row 3, multiply it by -1.5 and subtract from the first row, converts it to 0. So it'll be row 14, to convert to 26, it's 14 by -1.5, add it to 26, and it becomes 5. Once again, obviously that's done on the calculator. Then we can convert the second row, -0.5. If I multiply that by +0.5 and then add it, I'll get it back to 0. So multiply 14 by +0.5, comes to 7, add it, goes to 7. So now that the left-hand matrix here is all in the identity matrix form, the values you have here are the required answers that you want. So in this case, because we haven't changed the row orders at all, we have x, of course, x must be 5, y therefore is 7, and z is 14. And if it's a word problem, we then obviously put it into words to explain the answer in full.